Hi everyone, continuing on the previous videos about permutations and combinations now, let's look at an example. Right, let's say we've got n is 3, r is 2, so we want to be able to choose from 3 objects 2. Let's label them A, B, C, which is generic, because A, B, C could stand for any old thing. These could be names, it could be Tom, Dick, Harry, these could be cities, London, Milan, Tokyo, it could be subjects, English, maths, physics. So yeah, so that's what A, B, C, they're just labels, right? Right, well, let's remember there were 4 cases we looked at in terms of permutations and combinations. Okay, order not important, repetitions are allowed. What do we need there? What we need there is combinations, because order is not important. Alright. Let's first list it and then let's write down the formula applicable for this case. Let's list all the ways we can select 2 from 3. Well, AB is a possibility, isn't it? AC is another possibility. Let's see, BA is a possibility, BC is a possibility, CA is a possibility, CB is a possibility, okay, without repetition. Okay, now am I done? No, because so we've satisfied the case where there is no repetition. Sorry, why did I put yes? No repetition. So there's no repetitions here. Okay. Actually, no. Let's do the whole thing. Let's write all the possible ways I can select 2 from 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9 things here. Right. So order is not important. Now, if order is not important, it means that AB is the same as BA. Well, I've got AB here, I've got BA there, so we can cross one of them out because they're the same thing. Likewise, AC will be the same as CA. Why does CA cross that one out there? I could have crossed that one out instead of that one, but it doesn't matter. BC is the same as CB, so let's cross that one out. And okay, so we've reduced it by 3 there, so we've dealt with this case. Repetitions, well, repetitions are not allowed, so we can't have, once we've selected one thing, we can't select it again. So AA, we can't have that because that's repeated. BB can't have that, CC, we can't have that. So in other words, the total number of ways here is 1, 2, 3. The answer is 3 ways. Now if we appeal back to the formula I gave for this case, it's the form N choose R, combination R, N CR. With this case it is 3, from 3 choose 2, and the answer comes out to be 3. So there you are. I've applied it using the formula and I've done it actually listing it. Okay. So here's how we do combinations on a scientific calculator. If we look down here, you can see NCR. That's the combination button. And it is for the case without repetition. On the calculator, it only gives you without repetition. So in our example, we want 3 from 3 choose 2. So what we do first is we enter the value of n, which is 3, and then we want to use the combination button. We press shift because that takes us to the yellow function, which is here. So if we press divide now, that will actually give me NCR, and you can see it appearing in the calculator there, and then 2, and then enter. Answer is 3. Okay. Just to mention before we continue that this listing method might work well if you've got small number of n to begin with, but when n is pretty large, then does not become feasible, because bigger the n is, if you're doing it by the listing way, the bigger the chances of making an error, because you're going to kind of slip up somewhere by not listing everything. So in that case, the formula is important. Second case, order, repetition. Let's say order doesn't matter and we are allowed repetitions. Let's write the whole thing down again, AC, and then go through the same kind of procedure. B, C, C, A, C, B, A, B, B, C, C. Obviously, if you feel confident, you can just pause the video, try it, and then just follow it through. That's the best way to learn. Order not important. So again, AB same as BA, AC same as CA, BC same as CB. Okay, repetitions are allowed, so AA, BB, CC are allowed. So in other words, we've got 1, 2, 3, 4, 5, 6 ways. 6 ways. Now from the table of formulas, from part 1 of the video, the formula here is n plus r minus 1 over r, which in this case is 4, because n is 3, r is 2, so that's 3 plus 2 minus 1, that's 4, and then 4. For 4, choose 2, and the answer is 6. Great, so we've done it listing it and also using the formula. Okay, so combination where repetitions are allowed. For our example, n is 3, r is 2. Now, the calculator by default only gives us the case for with repetition, NCR. So we have to kind of adjust the number slightly. So if n is 3 and r is 2, what is out of now is n plus r minus 1. So that is 3 plus 2 minus 1. So that's 4 in our example. And then we choose, and then r is 2, so press 2 equals. So combination of choosing 2 from 3 where repetitions are allowed, the answer is 6. Okay, by listing it kind of helps you, I think it kind of helps you more intuitively think of what's going on, because if you just apply the formula, you know, from the formula you just can't see what's going on there. Okay, next order, 2 more to do. So let's say this order now, we've done order not matters, order now matters. Let's say there's no repetition. While I'm writing this, just think about the next step. Order matters. What does that tell me immediately? It tells me it's a permutation. Repetition not allowed. So in this case, it must be that AB is different from BA. AC is different from CA, and so on. So we have this one, we have this one, we have this one, then that means we also keep the ones BC, even though we've got CB somewhere. Yes, there you go. So we keep all those. 1, 2, 3, 4, 5, 6. Repetition not allowed, to out, out, out. So what does that give us? It gives us 6 ways. 1, 2, 3, 4, 5, 6. Okay. Now the formula for this is n factorial, n minus r factorial, which in this case is going to be 3 factorial over 3 minus 2 factorial, 1 factorial, and that is 6. On to the case for permutations without repetition. So in our example, we want 2 from 3. We want to know the permutation of that. We press n first, which is 3. Permutation, now that is here, NPR. To get that, we press Shift and the times button. It appears, P appears on the screen, and then press 2. So the arrangement is 6 ways where the order matters, and this is for the case without repetition. I'll show you how to do this on a calculator as well, although you don't need a calculator here, obviously. 1, 2, 3, 5, 6. So there you go. Final one. Order yes, repetition yes, So we'll list all this lot again. C. Now, order is important, so that means we keep this lot from the same as before. Repetition is allowed, so that means we're now allowed A, B, B, C, C. So in other words, we've got 9. 6 plus 3. Answer is 9. From the formula, we know in this case we have to apply n to the power of r, which in this case is 3 to the power of 2, 9. Fantastic. Simple as that. Okay, so permutations where repetitions are allowed. So n is 3, r is 2. In our example, we know we have to do this 3, and then we want to the power button. So on a calculator is this x with a big square over it, like that. 2 equals 9, just like that. Easy. Okay, because I like pictures, here is a table I've drawn, which kind of works when n is small. But for the permutations, I want to show you that also you can represent it in terms of a table. So let's say, since order matters, we're talking about permutation now. Permutation, order matters, we have A, B, C, so we could write A, B, B, A, when we're choosing 2 from 3, where there is no repetition, for example. We can have what else? A, C. Now this way is not good. It's not very systematic. What we should start off with A and just do all of A's. So let's start off with A. A can go with B. A can go with C. Right, we've done all A. So next go on to B. B can go with A. B can go with C. Alright. Next we can do C. C can go with A. C can go with B. Alright. So this is permutation without repetitions. And what I've done here, up here, is the ordering, yeah, because 1 order, 2nd order, 3rd order, and we know that A followed by B is different from B followed by A, so this kind of table could help. Another way, if you don't like, or yeah, if you're not into the tables, we can use this in terms, we can express this in terms of a tree. Look, we have A, then A can go to B, C, so this is like 1st position, 2nd position, 3rd position. There's no 3rd position because we're not selecting it. Or you can have B go to A, it can go to C, and C, you can go to A, you can go to B. Gives you the same thing. Look, AB, that's 1 outcome, AC, that's the 2nd outcome, BA, 3rd, 4th, 5th, 6th. Same as 1, 2, 3, 4, 5, 6. Depends on what picture you prefer. Now, if repetitions are allowed, you could have A followed by A again, B with a B there, C. So you'd have 9. Fantastic, fantastic. So that is permutations and combinations demystified. I'm Phil, Statistics Mentor.